Okay, section 4.3 is on page 286, talks about dividing polynomials, and let's get division out of the way. If I wanted to divide 19 by 3, I would say, well, there's 19, there's 3. 3 divides 19, I was going to say, you know what, let's go 199. So 3 divides 19 6 times. 6 times 3 is 18. You would subtract. Bring that number down. 3 divides 19 6 times. You multiply. That's 18. Subtract. So you would say this is 66 plus, how do you write the remainder? A 1, whatever's left over, divided by 3. That's how it works. If you clear the fractions, you could also say 199 equal 66 times 3 plus 1. So those are two ways you could write the division. We're not going to specify really which way to go. We just want to divide. So when I get to this problem, well, how do we divide? You make sure this is in descending order from highest power to lowest. And you start with 5x to the 4th plus 3x. Actually, I'm sorry. I want to do number 4 first. So let me leave this alone. Let's get to number 4. I want to do number 4 first. I forgot about that. 2x to the 4th minus 3x squared minus 12x minus 7 divided by x minus 2. We follow the same process. We take the first divided by the first. 2x to the 4th divided by x. So 2x to the 4th divided by x, that's really 2x cubed. And if you multiply this, that will give us a 2x to the 4th minus 2x cubed. Now, when you subtract, you change all the signs just like we subtracted right there. And those cancel out. Well, those don't match. Remember, you could only add like terms. And then once you get to this stage, you do it again. So, okay, what's 2x cubed divided by x? That is a positive 2x squared. Multiply those. That is 2x cubed minus 4x squared. And when we subtract, just like we did there, you really change all the signs. That becomes a negative. And that becomes a positive. Those cancel out. I'm left with x squared minus 12x minus 7. I need more space. Easy to do. And then we take we had 2x cubed, and then we had 2x squared. Now, we take x squared divided by x squared, that is a positive x, multiply, that's x squared minus 2x, that's it. When you subtract, you change both the signs. That becomes negative 10x minus 7, and negative 10x divided by x is negative 10, negative 10x minus 20, and when you subtract, you change both signs, and that becomes a 13. So I would say my answer would be 2x cubed plus 2x squared plus x minus 10, and the remainder is 13 over x minus 2. That would be my answer. Okay, I switched things around. I want to do number 8 next. I want to take negative 7x to the 5th plus 5x squared plus x plus 3 divided by x plus 3. And 7x to the 5th divided by x is negative 7x to the 4th. Multiply those. Negative 7x to the 5th plus 21x to the 4th. If you subtract, change the signs. Negative 21x divided by x is negative 21x to the 4th divided by x is negative 21x cubed, multiply those, that is negative 21x to the fourth minus 63x cubed. So you notice, every time you do this right, change the signs, this will cancel out every time. This is going to be 63. So remember, I can only combine like terms. Those are not like terms. Just be careful with that. 6x cubed divided by x is a positive 6x squared. Multiply those. 6x cubed plus 18x squared. Oh, wait a minute. Something's not right. Oh boy. Okay. This is a 63. I was going to say, why is the number getting smaller? This is 63. When you divide 63x cubed divided by x, that will be 63x squared. So that's 63x squared. 63 times 3, that is 189x squared. Subtract, change both signs. That will cancel out. That will be negative 184x squared. Bring the x, bring the 3. I'm going to continue on right there. So I'm down to negative 184x squared plus x plus 3 and an x plus 3. Negative 184 divided by x, that's negative 184. So x squared over x is x. A lengthy problem. I should have did this actually. I should have just kept the line, nothing more. Just the line. And now if I multiply this times that, that will be negative 184x squared. And 184 times 3, 12. 24, 25, 3, 4, 5. That's 500 and negative. That's negative 552x. When you subtract, those change signs. That's 553x plus 3. 553 divided by x is a positive 553. Multiply those two, that's 553x plus, what is 3 times 553? 9, 15, 16, 1659. I don't know why this book likes big numbers. And that will be negative 1656. So my answer to this problem would be 7x to the fourth minus 21x cubed plus 63x squared minus 184x plus 553 plus a negative 1656 divided by the divisor. That's how you write the answer. On a test, you could just leave it like that out of mind. Another way of doing division is using what's known as syntactic division. There's a small catch. Somebody figured out that, you know what, if you just copy the numbers down and just use the analogy of numbers, you could come up with the same answer. Syntactic division in the beginning is not liked by students, but once you see the benefit of it, I think students appreciate it. Let's show you really quick before we go on. Let me show you what that means. So, if I was to play with syntactic division, the nice part about it is it only takes a line to fill, but there's a catch to it. You start with the highest power constant, that's 2. Do you notice this is 4, there's no 3? You must fill a 0 for x cubed. Then for x squared, that's a negative 3. For x, so you can't skip a term. Any term that's not there, you fill a 0 for. Now, do you see how we subtracted every time? Every time we said change the signs. To compensate for that, they take the opposite of this. So if that's a negative 2, they put a 2 there. And if that's a positive 2, they put a negative 2 there. And that's how they deal with, and let me just line it up a bit nicer. So at 2, there is no x cubed, there is an x squared, there is an x, and there's a constant. And the way it works, it's fairly simple. You drop the first number. And this is going to be multiplied by whatever goes underneath that line. 2 times 2 is 4. You add. That's 4. Now that 2 gets multiplied by 4, that's an 8. You add. That's a 5. You multiply. That's a 10. You add. That's a negative 2. 2 times negative 2 is a negative 4. And you add and get a negative 11. Which means we messed up somewhere. Let me see where we messed up. Yeah, right there, the very first step. Look at that. Oh boy. Okay. I was trying to impress you, now we messed up. Okay. It was right here where we multiplied the very first step. Get rid of all of that. Let's do this back really quick though. So we take 2x to the 4th divided by x, that's 2x. When we multiply that, that is 2x to the 4th minus 4x cubed. When we subtract, we change the signs. That becomes 4x cubed, and you bring those down. See? 4x cubed divided by x is a positive 4x squared. You multiply, that's 4x cubed minus 8x squared. You subtract, change both signs. That becomes a 5x squared. Bring those down. You could bring them one at a time. You could bring the whole thing. I'd rather bring the whole thing. 5x squared divided by x is a positive 5x. 5x times this quantity, 5x squared minus 10x. Subtract. Bring the 7 down. And that's a negative 2. Negative 2 times x, negative 2x minus 4. And if you subtract, change both signs, that becomes a negative 3. Let me make sure. Nope. Right there. When you multiply, negative 2 times x is negative 2x. Negative 2 times negative 2 is a positive 4. When you subtract, you change the signs. That becomes negative 11. So the answer would be (2x squared plus) okay, 2x cubed plus 4x squared plus 5x minus 2, and the remainder is plus a negative 11 over x minus 2. Of course, you could make that a negative if you wish. And there it is. So you notice they were able to get the 2, the 4, the 5, and the negative 2. And they were able to get the remainder. So syntactic division is very useful. All what you have to remember is that whatever you start with, if you start with x to the 4th, this is 2x cubed, x squared, x, and the constant, and there's the remainder. Very useful for what we need. And what do we need? We need to factor polynomials. So we're learning about division, and the goal is to take any polynomial and factor it. And why do you want to factor polynomials? Because we're going to graph them. So let's look at this problem. Long division on this will be very lengthy, but syntactic division, we're going to take the opposite of that to compensate for subtraction. X to the 4th, there's a 1 there. X cubed, a 6. X squared, negative 19. X, negative 144. And the constant, negative 91. You drop the first number always. This is going to be multiplied by all of these numbers. There's nothing there. You drop the first number always. 5 times 1 is 5. Add. 5 times 11 is 55. Add. What is that? 36, if I'm not mistaken. 5 times 36. What's 5 times 36? 180. Right? And this is 36 positive. 5 times 36 again is 180. And if you subtract those, that's 89. And my answer would be, you start with x to the 4th. My answer would be x cubed plus 11x squared. And you move in order. 36x plus 36 plus 89 divided by x minus 5. Long division on this could take you some time. You should try it, whenever you have a lot of free time. Play with those. Again, this problem, use syntactic division. Let's take, again, to compensate for the subtraction, you take the opposite of that. So that is x cubed. There's no x squared. There's an x and there's a number. I drop the first number all the time. So the 1 I drop down. Multiply -6, add. Multiply 36, add. Multiply 180 minus 6, -100, 180 minus 174. And add, that would be -168. My answer would be x squared minus 6x plus 29 with a remainder of 168 over x plus 6. And the same deal with number 16. Again, syntactic division is very useful since we're going to be dividing a lot. It's worth really getting out of the way. The opposite of that, x cubed, there's no x squared, an x and a constant. Drop the first number, multiply, add those, you always add, -4, 16, that is a 12, -48, -45. So you start with x cubed, that will be x squared minus 4x plus 12, and the remainder is a -45 over x plus 4. Now I could really quick take x cubed minus 4x plus 3 divided by x plus 4. X cubed divided by x is x squared. Multiply those, that's x cubed minus 4x squared. Subtract, that's one of a kind. To bring this down, 4x squared divided by x is a positive 4x. Multiply. Why am I getting... When I multiply those, x squared times x is a positive 4x squared. When you subtract, that becomes a negative. So this is a -4x. Multiply -4x, that's -4x squared minus 16x. Subtract, change both signs, that becomes 12x, and you bring the 3 down. And the last stage, take a 12x divided by x, that's positive 12, multiply 12 times, that's 12x, plus 48. When you subtract, you change that sign, becomes a negative, and that's -45. So instead of doing all of this work, you can get the answer literally in that much work. And we're going to be doing a lot of division. If you'd rather use long division, we're never going to specify how to do this. It's up to you. Now, remainder theorem, something we should really consider. This is what it says. If a polynomial, here's a polynomial. If a polynomial is divided by x minus c, then the remainder is f of c. X minus c, what does that make c? That makes c equal -4. Always the opposite of this, right there. What is f of -4? F of -4 is, again, this is f of x. That is -4 cubed minus 4 times -4 plus 3. That is -64 plus 16 plus 3. That is -64 plus 15. That is a negative, let me see. What is wrong with me? That's 19. 9 minus 14 is a 5, and 1 minus 5 is a 4. And do you notice what just happened? I was able to figure out the remainder without doing the division. And how is that? By using the remainder theorem right there. The remainder theorem says if a polynomial f of x is divided by x minus c, then the remainder is the value f of c. And why is that important? Because there's something that didn't come up. I was hoping it's going to come up in this section so far, but it didn't come up. And that is, I'm going to add a couple of examples. That is, does 7 divide 1735? Well, how are we going to figure that out? We're going to divide 17. So be careful. We're just really following the trend of what we're doing. It's important to understand what you're doing. Why are we dividing? Well, we want to see if it goes in there. I'll show you what that means. 7 divides 17 how many times? 2 times. That's 14. Subtract. We just did that. That becomes a 3. I bring those 2 down. 7 divides 33 4 times. 7 times 4 is 28. Subtract. That becomes 13. That's a 5. Bring the power down. Bring the rest down. Again, I like to bring them always. I'm going to put that a bit on the side. So 7 divides 55 8 times. 7 times 8 is 56. Subtract. Oops. Too big. 7 times. 7 times 7 is 49. We say that's a 6. So does 7 divide 1753? We say no. How do you know that? Because the remainder is 6. What does that mean? If the remainder was 0, we would have said yes. Right? Another example. Does 3 divide 113? Assuming you don't know the rule. Well, so let's see if it does. 3 divides 11 3 times. That's a 9. Subtract. 3 out of 9 is 2. Bring the 3 down. That's a 7. 21. Subtract. That's a 2. Oh, wait. Oh, yeah. Silly me. Okay, I'm going to add another one. That doesn't divide it. That wasn't the goal. How do I know that? Well, I got a remainder of 2. 3 divides 11 3 times. You multiply, you get a 9. Subtract. That's a 2. Bring those down. 3 divides 21 7 times. That's 21. Subtract. And do you see what happened? I got a remainder of 0. If I get a remainder of 0, well, I know that means I could take 1113 and write it as 371 times 3. So 1113 equals 371 times 3, which means I was able to factor it. And that's the goal. So finding a remainder of 0 is a big deal. If I was to apply this theorem to the following problem, they're not really long, they're looking more on do you understand the concept or not. Use the remainder theorem to draw a conclusion about each polynomial. So here they say, look, on 18, what can you draw on p of x if p of negative 1 is 5? That means when p of x is divided, here, maybe I should write it out, means when I take p of x and I divide it by x, the opposite of that, plus 1, the remainder is 5. That's what that means. And if I get to number 30, p of x, if the remainder is 0, 1, p of x is divided by x minus 3. Well, if I take p of x and I divide it by x minus 2, I'm sorry, not 3, right? And I get a remainder of 0. If I take p of x and if I divide it by x minus 2 and I do my work and I get a remainder of 0, that means x minus 2 is a factor of p of x. Just like when we get a remainder of 0 right here, we said 3 is a factor of 1137, or 371 is a factor of 1137. So getting a 0 is a big deal, and that's what the next theorem says. The last theorem that we're going to deal with says, hey, if you take this x minus k, if this is a factor of this polynomial, then the remainder is 0 when you do the division. So now, how can we find a remainder? We could do the division. We could use long division, look at the remainder, syntactic division, look at the remainder, or we could just plug the value in by the remainder theorem. So here they say, well, let's see. What can you draw about the conclusion? What can you draw? Use the factor theorem to draw a conclusion. What conclusion can you draw about the polynomial r of x? R of negative 9 equals 0. Since the remainder equals 0, this means x plus 9, the opposite of that, is a factor of r of x. And that's extremely important. How about here? Remainder equals 12. Then x minus 8, the opposite of that, is not a factor of h of x. And in case you're wondering why do we need to know that, well, wait till the next section and it'll all make sense. We're going to try to factor everything, and we're not using traditional factoring. How about here? If I take m of 3 and I get a remainder of 0, that means x minus that is a factor of m of x. And the homework on this section is right there.